How do ML decision trees partition data? Have you ever wondered how machines learn to make decisions? One fascinating method is through machine learning decision trees. Today, we will break down how these trees partition data into meaningful groups. At the heart of a decision tree is the idea of splitting data. This process starts at the root node, which holds all the information. From there, the algorithm looks for the best way to divide the data into smaller, more homogeneous subsets. The goal is to create groups that are similar in terms of the outcome we want to predict. To find the best split, the algorithm evaluates different features of the data. It tests various split points and measures how well each split separates the data. There are several criteria used to assess these splits. One common method is Gini impurity. This measures how mixed the classes are in a node. A lower Gini impurity indicates that the groups are more uniform. Another approach is entropy, which looks at the disorder within the node. The aim is to reduce this disorder with each split. In regression trees, the sum of squared errors is often used to minimize the variance in the child nodes. The algorithm will go through each feature, testing different split points and calculating the improvement in purity or reduction in error. The split that provides the best improvement is chosen, resulting in child nodes that contain data subsets that are more similar than before. This splitting process is repeated recursively for each child node. As a result, the tree structure forms, where internal nodes representing decision rules based on features, and leaf nodes provide the final predictions or classifications. The recursion continues until certain stopping conditions are met. These conditions might include reaching a maximum tree depth or having nodes with too few samples. In practical terms, decision trees are a clear example of supervised learning. They learn from labeled data, making them easy to interpret and understand. This simplicity makes them popular in various applications, including more advanced methods like random forests and gradient boosting machines. Understanding how decision trees partition data is also relevant when looking at artificial intelligence models like ChatGPT or image generators, such as DALL-E and Midjourney. These models may use similar decision-making processes internally, especially when integrating productivity plugins that help optimize their behavior. Key concepts to remember include the root node, which contains all the data, the internal nodes that representing decision rules, and the leaf nodes that provide the final output. The process of recursive partitioning helps create a clear and interpretable model for both classification and regression tasks. So, the next time you think about how machines make decisions, remember the role of decision trees in partitioning data. They are a fundamental part of the machine learning landscape, helping to shape the future of artificial intelligence.